Homework helps for goal 6 in our acids bases unit. In neutralization reactions, if the moles of base equal the moles of acid, and in a titration this would occur right at the end point or the equivalence point. And we could use this formula. So molarity of acid times the volume of acid equals molarity of base times the volume of the base. So let's look in your homework question number 42. Write a general word equation for a neutralization reaction. So a neutralization reaction just means that we're taking an acid and we are adding it to a base. And we're always going to get water, and then we'll have a leftover. And it is a salt. So it is the conjugate base from the acid, and it is the conjugate acid of the base, so put together. All right, let's look at question number 43. Calculate the molarity of a hydrochloric acid solution if 25 milliliters of the solution is neutralized. So that's that neutralization point that we're talking about. That's when the moles of base equal moles of acid, so we can use this formula. So I'm going to write my formula down, and then I'm going to plug in what goes where. So I see that I have, this is my acid, and that's all I know about my acid. So I don't know the molarity. I do know my base. Now, as long as my units are the same, I don't have to change it to liters. All right, let's go ahead and do this math. So 0.8 times 15.5 divided by 25. And I get my molarity of my acid is 0.496. I have 3 sig figs, and it would be M. All right, let's skip to question number 45. So in a titration, we have 25.5 milliliters of 0.2 molar of my base is titrated to the end point with 42 milliliters of the unknown concentration of dilute hydrochloric acid. So this is more specific. So first of all, it asks what the net ionic equation for this reaction is. So this comes from that base plus the acid, or acid plus the base, it doesn't matter. And I'm always going to get water. And then I will have a leftover, and it would be NaCl. So you can see that Na is left over and the Cl is left over. And then there's my water. Now it's asking for the net ionic. So this is a strong acid and a strong base. And anytime you have a strong acid and a strong base, you will always get the following reaction. So I don't need to do this step. I can just write it like that. Again, anytime you have a strong acid plus a strong base, it will always be this water equation. What is the pH at the equivalence point? Because I have this strong acid, strong base, my pH will always be at the equivalence point a 7. So there's no math involved, it's just a memorization question. And that says, what is the molarity of this acid used in the titration? So I'm going to use my neutralization reaction. And I do know my base. I don't know my acid molarity. So 0.2 times 25.5 divided by 42. And I get 0.121, and that's my molarity. So in a titration reaction, you need to be able to identify your titration curves, what's going on. So these are the 3 types that you will have. You'll need to figure out what you're starting with and then what you're dripping into your solution. And the guide for this is to look at the equivalence point. So let me just sketch out some graphs. Okay, and on your homework you have more details, and I'm just sketching these out, so I'm just showing you that midway point. So let's come to this first graph. So on these titration graphs you want to find the equivalence point. The equivalence point is when it shoots up really straight at a certain volume that is added. So I can see that it shoots up straight right here. So what I'm going to do is I'm just going to eye the straight part, and it's going to be right around here. And then I'm going to look at the equivalence point. So the equivalence point is a pH of 7. And I know that if I'm at a pH of 7, then that's that first case, the strong acid and the strong base. So I just need to look and see, what am I starting with? Well, because it's a low pH, this is my strong acid. And then I'm going to drip in the strong base until it reaches that equivalence point. And then they did a little bit of overkill to complete the graph so it looks nice. This is excess strong base. So again, this is my strong acid, strong base. All right, let's look at the one at the bottom. Now the one at the bottom, when I eye the equivalence point, it's right around there. So I can see that it's above 7. So because it's above 7, I have a basic solution. So this means I have a weak acid, strong base. So if you want to look at it, because it's above 7, I would have a strong base in there. Really what's happening is the weak acid has a conjugate base that's hanging out with it also. And that conjugate base along with the strong base, it tips it above 7. So anyway, this is my weak acid right here that starts at a low pH. And then I can see that my equivalence point is above 7, and then they added excess base, but this is my strong base. So let's look at the one over here on the right. So let's find the equivalence point. So my equivalence point is right here, and I can see that it is below 7. So this is telling me that I have a strong acid. And then I know that it has to be a weak base, because if it was a strong base, my equivalence point would be 7. And I do know that it starts out basic because I'm above 7 right here at the very, very start. And then I see that we go to the equivalence point or the end point. The end point just means there's a color change. The equivalence point is when the moles of acid equal the moles of base. And so my moles of acid equal my moles of base right around like 6 or 5 in this graph here. So this, I'm starting out with my weak base, and then I'm dripping in my strong acid, and we see that the pH ends up being more acidic. So, and this is because the weak base is also hanging out with its conjugate acid, and the combination of the conjugate acid and the strong acid, it makes it more acidic. So this is how you do the graph. So find the equivalence point, figure out if you have a pH of 7. If you do, then you know that you have the strong acid, strong base combination. If you have a weak acid, strong base, your pH is going to be high because it's going to be basic. And if you have a strong acid, weak base, you know your pH is going to be low at that equivalence point. So first of all, your formula right here, it wants us to find the molar mass. So that's grams per mole. And in the problem, it does give us how many grams there are. But we do not know the moles. So we need to figure out how many moles there are. And let's look at what information they give us. So we have our molarity and our milliliters. And I know that to find the moles of my base, I would take the molarity of my base times the volume of my base. So, and this just comes from the molarity equation right here that I just rearranged. So to solve for this, I would get molarity of my base is 0.1704, and that's moles per liter. And I multiply it by the volume of my base. I'm actually going to get rid of that formula. I think it's just in the way. So we have 0.1704 moles per liter. And we have our volume. And I do want to have it in liters this time, and that's because I don't have that combination equation. So this is how many liters there are. So divide by 1,000 or move your decimal over 3. And when I do my calculation, the moles I get of base are 0.00725 moles of base. Well, what do I know? I know that at equivalence, the moles of base are equal to the moles of acid. So I do know that my moles of base are 0.00725. So that means that's the same amount I have for my acid. They'll be the same. So that was what I needed for that little question mark. So let's go ahead and fill it in. So 0.00725. So I just need to do the math there. And when I do the math, I get a final answer of 397 grams per mole.